Okay, so this is going to be the first video of our final review. So I'm going to go ahead and film the review for you so you know that you're doing it right. So what we're going to look at first is we're going to look at, I'm going to see how much I can get on here. I don't want the videos to be too long because some of you don't need to see all of the parts of the review, you just need to see some of it. So I'm going to try to avoid making 20-minute videos. I'm going to chop this up as much as I can. So on the first one, we have special segments. That's the foldable. Now you have a foldable for that. Let me see if I can, my OCD is kicking in right here. You have a foldable and it details all of these segments. So the first one is, given that AF is congruent to FC, so I'm going to kind of color code these. AF is congruent to FC. Okay. So we know this one and the whole thing, those are congruent to each other. So AF and FC. These guys are the same. Okay. It's kind of hard to see when it's a busy picture like this. So we did that. BH is congruent to HC. So BH and HC, these guys are congruent. Okay. And then it tells you that angle ABE, which is this guy, ABE is congruent to CBE, which is this guy. Okay. So now let's identify these based on their descriptions. Well, first of all, what is a midsegment? A midsegment connects two midpoints. Okay, it's the segment in a triangle that connects the two midpoints. So we need something that connects two midpoints. Well, look what we have here. We know that BH and HC are the same, right? And we know that AF and FC are the same, which means that F and H are both midpoints, which makes HF a midsegment. So segment HF is your midsegment. It connects the two midpoints in the triangle. That's what a midsegment is. Okay, angle bisector. An angle bisector is a segment, ray, or line that bisects an angle. Now when we say this, you got to remember what the word bisect means. Bisect means cut in half. So what are the only angle possibilities we have? We have angle ABE, which is this one, and we have CBE, which is this one. It should go here. So the angle bisector, the one that cuts those in half, is this guy, BE. And you can call it ray BE, line BE, you can call it whatever you want. In the picture itself, I believe it's a line or a ray. I'm just going to call it ray BE. We can call it line BE if it has a line on it, but it doesn't, so we'll just call it ray BE. That is your angle bisector because it cuts ABE and CBE in half. If you look at it, this guy has a BE and that has a BE. That means it's part of both of those angles. It's the side. All right, the perpendicular bisector. A perpendicular bisector, again, and we're going to say the same thing. It's a segment, ray, or line that bisects a side at 90 degrees, hence perpendicular. So if I look at the picture right here, I'm going to make it kind of a dotted line. BD is perpendicular, but is that a bisector? No, it's not. I need something that bisects at a 90-degree angle. So let's look here. How about GF? Well, line GF, that hits at F. Isn't F the midpoint of these two? Didn't we establish that? AF and FC are congruent. So we know F is the midpoint, and there's a 90-degree angle there. So line GF is your perpendicular bisector. Remember, a perpendicular bisector bisects at 90. And if you want me to draw little bitty pictures here, I can. Here's an example of a midsegment. Here's an example of an angle bisector. And here's an example of a perpendicular bisector. Okay, so those are little examples. All right, so let's look at median. Median, this is where bad drivers end up all the time. A median, okay, is a segment, ray, Okay, and actually, median we're going to call a segment. Okay, these are technically all segments, but you know, we can call them whatever we want for right now, because as long as they hit the proper properties, we're in good shape. But we're going to call them segments for our purposes. So a median is a segment that has endpoints at a vertex and midpoint. So I'm looking for something that hits a vertex and hits a midpoint. Well, here's your option right here. BF. F is a midpoint, B is a vertex, so BF is your median. And again, if you want me to draw a picture of it, there's your midpoint, there's your median. Okay. The last one is the altitude. And let's go back and look at what we did. Or see this dotted line here, BE? The altitude is the height. And it actually goes from vertex to side at 90 degrees. It is also perpendicular. And so your altitude, how tall is this triangle? That's where BE comes in. So segment BE is your altitude. So those are your special segments of your triangles. You have the altitude, the median, the mid-segment, the perpendicular bisector, and the angle bisector. Okay. All right, so let's look at a couple of examples applying these here. All right, find the value in this picture. Well, you see these two marks? That indicates that this is a midpoint. You see these two marks? That indicates that this is a midpoint. So, the mid-segment, if you remember, the mid-segment also has this special property. Not only does it connect two midpoints, it is also parallel to the opposite side and 1/2. So it's 1/2 the opposite side. So if this is 12, the mid-segment will be 6. Okay? The mid-segment will be 6. So in this particular picture, it's giving you 12 and it's asking you for the mid-segment. The n should be actually on the mid-segment, so it's asking you for n. It's not really being as particular as we need it to be, okay? So it's supposed to be the actual mid-segment itself. So let's look over here at the next picture. And we want to look at the next picture. Again, you see, that's a midpoint. These are same. That's a midpoint. These are the same. This is a midpoint, so these are all mid-segments, which means they're all half of each other. Now, it asks, what is the perimeter of the triangle? Well, if this mid-segment is 3, that means this whole thing is 9, right? We already know that's 9. We know that's 9. The question is, what's the other side? Well, how do we find that side? If that's 4, that's 4. So what's this side? Ugly 8 with ugly marker, which is going to be tossed right now. Bye-bye. So that is 8. Let's see if we can find another red that works. Oh, hallelujah. So we've got 9, 8, and 8, and it's asking for the perimeter. 9 plus 8 is 16 plus 9, which is 27. Okay, so that's your perimeter. Okay, so let's move down here. I'll try to get the whole first page in on this first video. It's getting a little bit long. Let's look at number 4. Given triangle ABC with median AD, that immediately tells you that's a midpoint since it's a median. If BD is 12x minus 4 and DC is 10x plus 10 and AD is 3x minus 5, find the length of BC. BC, it's doing some kind of a wrap thing. I don't know why there's 2 BCs there. Find the length of BC. Well, since AD is a median, that means D's in the middle. So what does that mean about these two guys? You're such a good student. You're right. They're equal. So 12x minus 4 has to be equal to 10x plus 10, right? So from here, we're going to do a little solving because we love doing that stuff. Let's get all the variables on one side. Minus 10x, minus 10x. So I've got 2x minus 4 equals 10. And let's do the constants and get them on one side. So I'm going to add the 4. So 2x equals 14. And then I'm going to divide both sides by 2. So x is equal to 7. Now, since I now know x, because I knew these two were equal, what can I do with this? Plug it in. So 3 times 7 minus 5 is 21 minus 5, which is 16. So AD is 16. Now, find the length of BC. Well, once we know x is 7, we've got AD, and what can we also do to find these two? Plug it in. And do you have to plug into both? Nope. You can plug into either one because they're equal. So 12 times 7 minus 4 is 70, so 84, so 80. Now 80 is how long this is. So what happens here? Same thing, and if you plug it in, you get 80. So how long is BC? 80 plus 80, which is 160. Okay, now we found AD. We found the length of the median. However, did we need that? No, we did not. We did not need the length of the median. That's what they call a distractor. Okay, you don't need that information. It's thrown in there though to distract you, and they call those distractors. And a lot of times they'll put those in word problems to see if you can determine what information you need and what information you don't need. So anyway, we've got the median, we have BD and DC, and we know those are equal. We set them equal to each other, found it at 7. We could have skipped the altitude, but I went ahead and showed you the input to show you what the distractor is and to practice your algebra. So once we put those in there, we get 80 and 80, and that's our answer. And I'm going to do number 5, and then we will move on to the next page. Okay, or we got number 6 on here. I'm just trying to score the video length because I know y'all love listening to my voice and watching videos. It's your favorite thing in the world. Okay, ABC has an altitude. It is obviously not drawn to scale. Altitude means vertex to opposite side at 90. So we've now got a 90-degree angle. It says the measure of angle ADB, that's this guy, ADB, which is 90, is equal to 5x plus 20. Find the value of x. Well, if it's an altitude, what do we know that that angle is? It's 90. So I know that 5x plus 20 has to equal 90 degrees because it's an altitude, right? ADB is 5x plus 20. So then I'm going to solve it because we're good at that stuff. So I'm going to subtract 20 from both sides. So 5x equals 70. And then my last step is going to be to divide. So I'm going to divide by 5. So x equals, and I believe that's 12. Actually, sorry, I'm sorry, it's 14. Trying to do mental math, that's what happens. So x is 14, and you are done. Okay, let's squeeze the last one in. Why not go for the whole first page? We're rebels, right? I'm sorry, I'm talking to myself. I'm fried from the sun this weekend. All right, triangle ABC, G is the centroid. Okay, do you guys remember what a centroid is? The centroid is the intersection of all medians. Okay, if we draw 3 medians, we get the centroid. That means these two guys are the same, these two are the same, and these two are the same because these are all medians. They all are midpoints. If BE is 9, okay, we're going to highlight this. BE is 9 all the way. BE is 9. Find BG and GE. Okay, so the two pieces. Now, here's the rule with the centroid. The centroid divides the median into 1/3, and 2/3. So, if the whole thing is 9, right? What's 1/3 of 9? 3. If you want to do it that way, you can do that. So that means the little piece is 3, and what's 2/3 of 9? 6. So that means this piece is 6. The centroid is always divides all the medians into 1/3 and 2/3. So if the median is 15, that means you've got 5 and 10. If the median is 12, you've got 4 and 8. That means that the smallest one is actually half of the biggest one. Okay. So your two answers are 3 and 6. And BG's, you're too young for that, is 3, and GE is 6. Okay, and we've completed the first page of the review.